Part 2. The Physical Laws, Newtonian and 20th Century Physics. Introduction to Part 2. In Part 2, we try to understand matter and energy, and the power laws that drive them. Because physics is about the nature of matter and energy, it clearly has implications for the nature of the universe itself. The power laws of physics rapidly become the way in which we perceive the universe. The way that physical laws operate supplies the template, metaphors, and patterns for much else besides. For our models of thinking, our views of society, industry, and markets, our view of how individual humans behave and what we are, and even our most fundamental views about God and the coherence or meaning of life itself. Chapter 6 recounts the wonderful impact on the world of Newton's laws of motion and gravity. Meanwhile, in a parallel universe, as we'll see in Chapter 7, Einstein's special and general theories of relativity began the process of subverting Newton's physics. Initially just a bizarre curiosity, and yet to find any practical application, the theory of relativity has gradually changed our view of reality, time, and space. It does have interesting implications for business, as long as we don't spend too much time pondering them. The real hammer blow to humanity's ordered universe came with quantum mechanics. Chapter 8 tells the story. Although initially the implications of quantum theory brought perplexity and despair, some popular science writers have recently developed a populist quantum philosophy that domesticates the theory and suggests some fashionable implications for individuals, business, and society. We examine these theories with a sympathetic yet ultimately skeptical commentary. We can, however, learn from quantum mechanics at least one invaluable lesson: that the opposite of a great business truth is another great business truth, and that a both-and mentality can therefore transcend what often appear to be inevitable conflicts. Chapter 6. On Newton's Laws of Motion and Gravity. Nature and nature's law lay hid in night. God said, "Let Newton be," and all was light. Alexander Pope. Newton's impact on the world. Sir Isaac Newton, 1643 to 1727, showed that there are some basic universal laws, identifiable by precise mathematical relationships, that govern all physical movements on Earth or in the heavens. You can predict what will happen if you put a ship on the sea or roll a penny down a chute. With Newton's 3 laws of motion and his law of universal gravitation, you can build bridges, fly planes, or send men to Mars, and be pretty confident of the results. Newton's Philosophiae Naturalis Principia Mathematica was published in Latin in 1687. Here is the English translation of his 3 laws of motion. Law number 1. Every body continues in a state of rest or of uniform motion in a right line unless it is compelled to change that state by a force impressed upon it. Law number 2. The change in motion is proportional to the motive force impressed and is made in the direction of the right line in which that force is impressed. And law number 3. To every action there is always opposed an equal reaction, or the mutual actions of 2 bodies are always equal and directed to contrary parts. Newton's first law is that things keep moving forward in a straight or right line unless interfered with. This is a restatement of Galileo's law of inertia, that bodies remain at rest or in constant motion, except when moved by an outside disturbance. The second law is that force, denoted by the capital letter F, is directly proportional to the change in momentum that it generates. Twice as much force will cause twice as much change in an object's momentum. Newton provided an original definition of momentum, mass times velocity, where mass, represented by the lowercase letter m, is the quantity of matter in an object. Change in velocity is the same as acceleration, represented by the lowercase a. Hence, Newton derives his famous formula, F equals ma, or force equals mass times acceleration. The third law of motion, Newton's most original insight, is that every action produces an equal and opposite reaction. If similar objects collide, they bounce off with equal force. If an object's motion is disturbed, its momentum changes, then the motion of another object must also be disturbed so that the aggregate momentum is unchanged. The second disturbance must be precisely equal to the first, but in an opposite direction. From these three laws, and Galileo's law of uniform acceleration, Newton arrived at the concept of gravity. An object falls to the ground and its momentum increases. Newton's three laws say that some force must be responsible for acceleration, and this force must be constant if, as Galileo showed, acceleration was constant. This force must therefore be gravity. He concluded that the force of gravity on an object is constant and directly proportional to the mass of the object. Hence Newton's law of gravity, also known as his inverse square rule, that between any two bodies, the gravitational force is proportional to the product of their masses and inversely proportional to the square of the distance between them. The most important external force, whether on Earth or in the sky, is gravity. Newton's laws of gravity, together with the data and laws provided by astronomer Johannes Kepler, finally established that the Earth revolves around the Sun, and not the other way round. Newton showed that the planet's movements around the Sun fitted the equations of gravity, but required, for the calculations to work, slightly elliptical orbits around the Sun. Planets try to go straight, but gravity forces them into a curve. The orbits can be calculated if we know the mass of the planets and the distance, and hence the inverse square of the distance, between them. Amazingly, what holds the planets in place is the same as what makes apples fall off trees: gravity. Once gravity is appreciated, the heavens can be seen to move, not randomly or in a complex pattern, but just like clockwork. Gravity bends the movement of planets and moons, and the extent of gravity is a function of how close an object is to the Sun or other force of gravity, and the relative mass of the object and the Sun. In the overture, we saw that Newton was a synthesizer of centuries of scientific insight, and in many ways he became a symbol of a new scientific perspective. In praising him extravagantly, contemporaries and later writers were really celebrating a new sense of intellectual coherence and liberty, in which Newton played a leading but well-supported role. Nevertheless, he and his colleagues changed the world. Newton's amazingly economical theses on motion and gravity showed how a few simple rules, worked out from first principles and validated by mathematical proofs, could have universal application. The popular implication was that the world was predictable and controllable by scientists and engineers. This was deeply reassuring and inspiring, and remains so today, even when we know that Newtonian physics is incomplete and very slightly inaccurate. Are Newton's power laws old hat? It is common these days to denigrate this heritage and point out that the Newtonian mechanical and rational view of the world has huge and distorting gaps. We'll come to these in the next few chapters, but the reaction has slithered too far towards fashionable but glib notions, taking for granted or ignoring the terrific value provided by Newtonian tools and concepts. Where would we be, for example, without the simple ideas of profitability and the power of comparing a few simple and universal numbers, return on sales, return on capital, and the internal rate of return on a project or investment? Would we be wealthier with or without the idea of budgets and the practice of reviewing them? Is it sensible or just old-fashioned to look for a few causes determining success or failure, to identify common characteristics, and to test our theories with numbers? And would we really be better off without the machine metaphor and the mechanical view of life, the universe, and everything? A thought experiment. A world without business numbers. Imagine that you had used time or space travel to visit a sophisticated economy that had thrown away or never used the Newtonian tools of business. I'm going to be generous and give this imaginary world the benefits of technology, teams, corporations, computers, stock exchanges, and nearly all of the apparatus of modern economic life, even though I could plausibly claim that these mainly derive from Newtonian methods. But this imaginary world does not have accounting systems, or the ideas of return on capital, or discounted cash flows. For all their defects, imagine being able to make investments using these methods, selecting by apparent magic the most profitable and promising companies. How long do you think it would take you to become the richest person on the planet? Perhaps the reason that business writers find it more attractive to rubbish the rational, machine-based, analytical approach to business than to celebrate it is that there is little to add to the rational school. A long line of management thinkers, from Frederick Taylor to the Harvard Business School writers, culminating in the microeconomic analysis of business positions by Professor Michael Porter, has mined this seam so well that there is apparently little more to say. Taylor's The Principles of Scientific Management came out in 1913, and Porter's groundbreaking Competitive Strategy in 1980. Between these two dates, virtually everything of a Newtonian and rationalist nature that could be said about business relationships and what determines profitability was said, and said well. Yet not quite everything. The golden age of Newtonian business analysis may be over. However, in my view, one key insight has been insufficiently appreciated, and another overlooked altogether. The rest of this chapter explores these insights. Action and reaction. First, a short note on the one that has been noted, but perhaps not given due weight. Newton said that action and reaction are equal and opposite. Loosely interpreted, this means that any powerful development, whether a school of thought, a new technology, or a new market, will bring in its train an equally significant opposite development. We can see this clearly in the realm of ideas or proposals for organizing society. Capitalism produces socialism. The experience of trying to make socialism work produces a neo-capitalist revival. And the primacy of global free markets will doubtless produce another powerful backlash. As I've just commented on the same theme in business ideas, because the rationalist, Newtonian school of business thinking has been so powerful, it has conjured into existence an opposite, systems-based school. Ideas and actions break inertia, and once inertia is broken, reaction is inevitable. Applied to business and markets, this simple insight is an almost infallible guide to what is around the corner. Never mind the important new market. think about the one after that, its opposite. Thus, Henry Ford standardized and mass-produced the modern car. The next stage was General Motors' production of a range of different models, pitched at different levels. Once an effective, publicly owned healthcare system is introduced, this creates a large demand for private healthcare, a counterintuitive but clear relationship. The same applies to education or any other service. Once there is a mass market in anything, there is a demand for the opposite. Niche markets tailored to particular customer groups. Once there is broadcasting, there is narrowcasting. The beauty of the dynamic is that it works both ways. Once there are expensive luxury products, there is a demand for a stripped-down economy version. Are luxury hotels, planes, and boats the norm? Then mass tourism will emerge. Are package tours prevalent? Then the market for something superior and tailored will reemerge on a large scale. Do businesses find constant traveling an expensive nuisance? Then video conferencing and the internet can be substituted. Are the latter important? Then the virtues of face-to-face communication will be rediscovered. Are doctors, nurses, and hospitals an important part of modern society? Then alternative medicine will thrive. New technology and markets often fail to have the drastic impact on their predecessors that is confidently predicted. Personal computers breed prolifically, and gurus pontificate on the paperless office, yet paper and photocopying persist. The phone, the fax, the internet, and video conferencing do not stop meetings or travel or book reading. Nevertheless, this observation is a slight hors d'oeuvre. Now, for the main course. The gravity of competition. There is one direct parallel between Newton's law of motion and the nature of business that has been overlooked, that between gravity and competition. I think I can establish that this has definite metaphorical and conceptual value, but it may even be possible, in the fairly near future, to use Newton's principles to establish a quantitative or inverse correlation between exposure to the largest competitor and the return on capital earned by a business in a particular competitive arena. Let me first explain the concept, using the metaphor of gravity. Competition is a grave affair. It is the economic equivalent of gravity. Just as gravity depresses objects and stops stars going straight, so competition depresses returns on capital. Margin gravity depresses managers and investors. The extent of margin gravity is proportional to the proximity and power of competitors. Weak gravity indicates distant or tangential competitors. Strong gravity implies close, in-your-face competitors. Black holes. A black hole is formed when a huge, heavy star burns up all its fuel and collapses so far that nothing can escape from it. No light, nor any other kind of signal can emerge. Black holes only occur if the star is really heavy, about 3 to 6 times heavier than the Sun, according to Einstein's theory of general relativity. When such an enormous star dies, a black hole collapses all the space around it. The resultant megagravity curves the adjacent space to a fantastic degree. The gravitational pull approaches infinity. The business black hole is a useful metaphor describing competition so intense and head-to-head that margin gravity approaches infinity. No profits or positive cash flow can escape from the black hole. Competition-free zones. There are places that are free, or virtually free, from margin gravity. These are spaces where competition does not operate, where margins are limited not by competition but by what customers can afford, and by the distant hiss of competition from all other products and services clamoring for the customer's wallet. These non-competitive spaces, where gravity doesn't work, are the most beautiful places in the economic universe. Corporate gravity. How near and large is your competitor? What stops your firm moving forward in a straight line and achieving its business plan is pesky competitors. Competition is the corporate equivalent of gravity. It brings you down to earth. If you bang up against a competitor, you will both be thrown off course. The force of competition is a function of two things: the relative size, or more precisely, mass, of your most important competitor, and your distance from that company. A small and under-resourced but very adjacent competitor may cause you more trouble than a huge, rich, and successful corporation that is only marginally interested in your markets. What is size? Size, or mass, really means the resources that a competitor can devote to a market. It implies profitability, skill, and fitness to serve customers more than simple size and revenues. Size can also mean strength of balance sheet, ability to get new capital, a firm's price-earnings ratio, and the strength of its reputation, brands, and relationships. Until we can measure these aspects of size quantitatively, a good proxy may be one that has been used in business since it was invented around 1970 by the Boston Consulting Group. Relative Market Share, or RMS, which is your revenues in the business segment divided by the revenues of your largest competitor. If this number is over 1.0, it implies that you are the segment leader. If less than 1.0, that you are smaller than the leader. If exactly 1.0, that you are co-leader with one of more rivals of the same size. What is distance? Distance is the extent to which the competitor is close to your own customers. A distant competitor is one whose focus is elsewhere. A close competitor is one that has the same target market and the same approach. Distance can usefully be envisaged as a series of ever larger squares, with the corners being 1. Customer type, 2. Product type, 3. Geography, and 4. Type of value added provided. For example, research and development, production, distribution, marketing, sales. Either an integrated operation or a specialist by stage of value added. If you and a competitor are serving the same type of customer with the same type of product in the same geographic area and providing exactly the same type of value added, there is virtually no distance between you and the other company. You are on top of each other. The converse also applies. The distance is huge if the customers, products, geographic markets, and type of value added are all different. A crude scoring system to calculate distance is to score any business segment on these 4 dimensions as follows. 1 equals identical or very similar. 2 equals adjacent, close, similar, but with a few differences. 3 equals neither very close nor very distant, considerable overlap. 4 equals not very similar or close, but some overlap. And 5 equals distant, dissimilar, fundamentally not the same. You can then calculate distance on a scale of 1 to 625 by multiplying the 4 numbers, the scores on the 4 dimensions. For example, competing with the same customer type and product in an adjacent geographic area, but with a very different value-added focus, will produce a score of 1 times 1 times 2 times 5, equaling 10. A score of 8 or below indicates dangerous proximity. Anything below 20 indicates close competition. After making the calculation, your nearest competitor may not be the one you first thought of. In this case, you'll need to calculate the size of the competitor you now think is closest. Remember also that the calculations shouldn't be made at the overall corporate level, but within each separate business segment, where the competitors or customers or profitability or strategy are different.